Hi everyone. This video is on the properties of the graph of a log function. So I'm going to start off with something that we've seen before, which is y is equal to 2 raised to the x. And if you'll recall, that is the graph of an exponential function. And I'm just going to do something a little different here. I'm going to add a table. And in this table, I'm just going to type in, let's say, -2, -1, 0, 1, 2. So just grab a few, well, I'll go 3 as well, I guess. I'll just grab a few values of x around the origin, some negatives, some positives, as well as 0. And in y1, what I'm going to do here is I'm going to type in the expression 2 to the x. Okay, so essentially this is a, well, I guess 2 to the x1, right? So essentially what this will be is it'll just grab some points on our function, on our exponential function y equals 2 to the x. Great. Okay, so we can change this up. We can change it to, actually we can't change that to 3 to the x. I'd have to change it here as well. But what we can do is now I'm going to create a table that's sort of the mirror image of the one that I previously created. So in the first column, for the independent variable, I'm going to type in 0.25, 0.5, 1, 2, 4, 8. Which is identical to this column right here. And then in y2, I'm going to type in -2, -1, 0, 1, 2, 3. Okay, so I do know how to go from, in this table, I do know how to go from x1, I do know how to go from values in this column to values in this column. Right? Basically, what I'm doing is I'm using the values in this column as the exponent of a power of 2. What I don't know is how to go from this column, this value, back to this value. Right? But that's okay. I don't actually have to type it in there. I can just type in the values that I should get. And you can see that it's seen in purple here on the graph. Okay. So now what I'm going to do is I'll introduce the log function. Now the log function is precisely that function that will actually pass through each of these purple points. Now the log function would be typed in as y is equal to log base 2 of x. And if I just change that to a purple, if I have that option, then it'll just kind of make sense there, right? So the log function is what this purple function looks like. But you saw how I actually came up with that purple function. It is precisely the function that passes through those points. And those points are precisely those points that are generated when we reverse this table. Now, if you remember in your previous studies, you might have learned about inverses. And so what an inverse does is, for a particular function, you enter in x, and it gives you an output value. Well, then the inverse would then take that output value and return your original value, or your x, to you. So what we've learned here is that this purple function is precisely the inverse of the blue exponential function. And the purple function is what we call a log function. So the most important thing that you can take away from this video is to know that exponential functions and log functions are inverses of each other. Okay. You might recall also that when you graph two inverse functions, they are reflections of each other across the line y equals x. So there's y equals x, and you can see that if you were to fold on that line, quote unquote fold, that one function would map onto the other function. Okay. So I'm going to clear this now, and I'm just going to show you, excuse me, these two functions that are inverse functions. Now, if I were to adjust one function, let's make it a little bit more obvious. If I were to go y equals log base 5 of x and leave the other function as log base 2 of x, well, they're not going to actually be inverses anymore until I change the base to 5, right? So now if I add in the reflection line, y equals x, you can see that these two are reflections of each other across that line. And then just one other thing I wanted to do is to just focus on this particular graph here. Let's not make it so sharp of a turn. Let's make it 2. If you look at this graph, you will recognize that the domain is limited. It's limited on the left-hand side, right? And so as I zoom in, you can see that the y-axis, well, the graph doesn't touch the y-axis, right? Where it looks like it does, if I zoom in even further, there is some separation indicated there. So the y-axis is in fact a vertical asymptote. But there is no right boundary, right? And so the graph is allowed to keep moving to the right, excuse me, as you know, as far as x will take it, which is to infinity. So the domain here is x is greater than 0. The range, though, it goes forever downwards and it goes forever upwards. So the range is all the reals. And for all intents and purposes, well, let's just see what happens. If I put in a negative there, nothing happens. If I put in a 0 there, nothing happens. And in fact, you should know that the base, and this is what we call the subscript here, the base of this log function has to be positive, but not equal to 1, right? If it's equal to 1, we don't get anything either, so it has to be positive. So I could go 0.3 and it would still give me something, right? And so you might want to compare 0.3, or let's go 0.5 to, let's say, y is equal to log base 2 of x. Okay, and you might notice something there. What do you notice about these two graphs? And what do you notice about these two bases? Okay, and if I were to go 0.1 and change this to 10, what do you notice about those two graphs? And what do you notice about those two bases? Okay, so that's the log function. Key point is that it is the inverse of a corresponding exponential function. The domain is x is greater than 0. The range is all the real numbers. This one doesn't have any y-intercepts, but it does have an x-intercept, and in this case, it appears to be 1. Feel free to go on Desmos and play around with this, and try graphing some other log functions to see what you see.